Hey everyone, in this video we're going to be applying the area to the left of any given z-score. We're going to use this to solve more complex problems involving things like IQ and SAT. So let's get started. Alright, to get a better sense of what this problem looks like, we're going to jump over to the computer. So let's go through some examples together. Alright, so this is how it's going to work. I'm going to set up the problem with you guys, and then we're going to pause the video, and then we're going to go over the solution. Now, this is technically an application problem, which a lot of people associate to word problems, but I'm not going to throw a bunch of words at you. I'm going to actually just set the problem up as I introduce this problem. So here we have the IQ bell curve. Some facts about the IQ bell curve. The average IQ is 100. And the standard deviation is 16. And those two numbers are pretty much always given to you by your statistics teacher or whatever statistics class you're in. Now, that being said, here's the problem. I'm going to give you an IQ score, and I want you to tell me what the area to the left of that bell curve is. And I'm going to frame this question in 3 or 4 different ways so that you can understand what this question is saying, and so that you know what your professors or teachers are saying when they ask these questions as well. So here I have an IQ of, let's do 93. And I want to find the area to the left. I want you to tell me what this area is. Now, there's a bunch of different ways of saying this. If I were to write this out using math notation, this is what that would look like. I'm trying to find the probability that IQ is less than 93. So this would be an example of what you would see. Some people don't, well actually most people don't use IQ, they actually just use X instead of IQ, but I like IQ because I like naming my variables what they are. So these numbers on this number line, if you remember, are IQ scores. So try to figure out what the probability that my IQ is less than 93 is. Another way of saying that is, if I have an IQ of 93, how much percent of the population has an IQ that is lower than mine? That's another way of saying this. That being said, let's try to solve this problem. Now, we've never really talked about the IQ bell curve much. You might know the average, it's 100, the standard deviation 16, but that's about as far as we know. We don't know the area to the left of 93. We don't know the area between 97 and 117. We don't know much about the IQ bell curve. But that's okay because we didn't master the IQ bell curve. We mastered the standard normal distribution. So I'm going to quickly draw that bell curve for you. So this is the standard normal distribution. And the thing is, this standard normal distribution is basically the same bell curve. Look at these two shapes. They're both pretty much the same. If you remember that lecture, we talked about that. Oops, let me redraw my bell curve there. So we have an average of 0. That is the average of the standard normal distribution. It is 0. And the standard deviation is 1. So this is the z-score bell curve. Now, if we can find the corresponding z-score that corresponds to an IQ of 93, if we can find whatever this z-score is, then the properties of that z-score are the same as the properties of this IQ score. Basically, that's another way of saying that the way this 93 works on this IQ score is the same as this z-score works on the z-score bell curve. So let me show you one application of that fact. The area to the left of the z-score has to be the same as the area to the left of an IQ of 93. Because again, if this IQ score corresponds to this z-score, then the area to the left is the same as the area to the left over here. So these two regions need to be exactly the same if this 93 corresponds to that z-score. So let's try to figure out what that z-score is, because if we know about what the z-score is, we can find the area to the left. I know how to do that because I have a z-table to help me do that. Now there is a really important formula that we're going to be using here that we developed, and that is z equals x minus my average divided by my standard deviation. Now let me remind you what each of these things mean. This is the z-score that I'm trying to find, and this is an x, which is just whatever my variable is. It could be IQ scores, ACT scores, SAT scores, height, whatever my variable is, that is my x. And it's also the number that I'm trying to convert to a z-score. So I'm trying to find the corresponding z-score with this x. So this x would be 93 in this instance, because I'm trying to find what z-score corresponds to 93. So I'm going to try to find the z-score that corresponds to an x value of 93. Now the average IQ is 100, and the standard deviation of IQ is 16. Now it's important to understand that I used these two statistics rather than these two statistics. The reason for that is because if we use the statistics for the z-score bell curve, well, nothing changes, because if I subtract 0, that does nothing, and if I divide by 1, that does nothing. And that's kind of also the cool thing about z-score is using these numbers 0 and 1, it makes math really simple when we're subtracting by nothing and dividing by 1. So we need to figure out what 93 minus 100 divided by 16 is. And I have a calculator right here. 93 minus 100. Now, it's important, I don't know if we can see this real quick, but it's important to understand that if you do 93 minus 100 and then hit divide by 16, it's going to do 100 divided by 16 first, and then do the subtraction. The reason for that is because calculators follow the order of operations, PEMDAS. So we actually need to force our calculator to do the subtraction first and then the division, because we need to do that in that order. So I'm going to do this in two ways. I can do 93 minus 100 and then hit enter, and I get -7, and then divide that number by 16, and that gives me my answer. The other way you can do this is you can just put 93 minus 100 in parentheses. And if you do 93 minus 100 in parentheses, you're literally telling your calculator that is the first thing I want you to do, and then you can divide by 16. And either way, I get z equals -0.4375. Now, am I done? Well, not quite. The reason I'm not done yet is because I'm trying to find this area right here, and I have not done that yet. What did I just find? I found the corresponding z-score, the thing that goes right here, which is -0.4375. Now understand something about that z-score. Z-scores on our table are rounded to 2 decimal places, and areas are rounded to 4 decimal places. So I'm going to round this z-score to the nearest hundredths place. So this would be -0.44, which is just -0.4375 rounded to the nearest hundredths place. So now that I know what the z-score is corresponding to 93, then the area to the left of -0.44 should be the same as the area to the left of 93. So now I'm going to use my table, and I'm going to pull up my table with you, and I'm going to show you what to do with that table. So here we have a table, and we're looking for -0.44. Now this is the wrong side of the table because these are the positive z-scores. I'm looking for a -0.44. And if you look at this, it's kind of hard to see, but here's the -0.4 column. Excuse me. Maybe I'll just write it. There we go. Pulling this up. Here we go. So that's -0.4 right there, and then these are the hundredths places right here. Now this column represents a hundredths place of 0, 1, 2, 3, and 4. We're looking for -0.44, which would be this number right here, 0.3300. So the area to the left of the z-score of -0.44 is 0.3300. that's really important. Let's go back real quick to, here, I'll just use my mouse. My mouse is, or my pen. My mouse isn't working, but that's okay. We'll still work with this pen. So that means that this area right here is 0.33. Now, if that area is 0.33, then that means that this area is also 0.33 because the properties of these two values are exactly the same because the bell curves are pretty much exactly the same, just different numbers. So these two numbers correspond to each other, so the properties correspond to each other. So this area is 0.33, therefore this area is 0.33. And that's my answer. The area to the left of an IQ of 93 is 0.33. Another way of saying that is that the probability that my IQ is less than 93 is 33%. Another way of saying this is if I have an IQ of 93, then 33% of the population has an IQ lower than me. So I'm basically the top 67%, which is not that big, but still top 2/3. Another way of saying this is, yeah, a third of the population has an IQ lower than me. There's just so many different ways of saying this. Anyways, I hope this helps. Thank you guys so much. I'll see you in the next lecture.